I want to say before I pass it on, what do you think these are for? These big things right here. So what are they called? Fins. And what do you think they do for this? Why do I put them on the rocket? So it goes what? I didn't hear it. Just say it a little louder. I'm sorry. Speak up. It's okay. You can say it. It's all right to be wrong if you're wrong. What do you think it does? Why do you have those little feathers on the back of the arrow? Anybody know? Are you guys listening? You're playing with the tools I gave you there. Okay. Hey, listen up, guys.
Hey, listen up, guys.
The fins are to make the rocket go straight. Okay. You want to know what happened if you didn't have fins? We might even show you here what happens if you launch a rocket without fins. It's going to do this. Tumbling on the way up. Okay. The fins make it go in a straight shot, right? And that's what stability is. Here, I'm going to let Dan talk about why stability is important. Dan, you want to chime in? He's got an example.
All right, guys, listen up, guys. Come on.
I'm going to take
Hey,
it
guys,
away.
listen.
I'll pass this around.
All right, so I'm here to talk about stability. Why do we have fins? It's because it goes straight. If you don't have fins, the rocket's going to go whatever direction. It's going to tumble. If it tumbles, it doesn't go as high, it goes slower. It's no good. So what stability is an object's inclination to stay in its current position. So if you've got a ball, and if I put this ball on a hill, it's going to roll down the hill, right? So if I put this ball on the top of the hill, it's going to go left or right. That's called instability. That's no good. That's bad. If I put a ball on the top of the hill, it's going to roll down. It's going to go somewhere else. If I take
that,
okay, so that's no stability right there. If I want stability and I put it at, say, the bottom of the hill, what's it going to do? Well, if I roll it a little bit to the side, it's going to roll back down. If I roll it to the other side, it's going to roll back down. That's called stability. What happens is any tiny change in what we've got, it's going to go back to that position that it was. What the fins are going to do is give us stability. So what I've got here is I've got a weight on the end of a stick, right? Now you can think of the weight as like your rocket's weight. And you can think about me down here with my hand as what the fins are going to be doing. So the rocket weight's going to be up here and it's going to want to go this way. The fins are going to push the rocket back straight. So, you've got a rocket, you've got the fins kind of pushing it up like that. What happens is that weight and the distance between the weight and those fins are going to keep it going straight.
What's up, guys?
So if you've got the weight closer to the bottom, and I'm trying to balance it the other way, it's going to fall up, it's going to fall over easier. Yes, you got your hand up.
Are you going to balance plates on that?
No, I'm not going to balance plates on this. First of all, I'm terrible at balancing anything. I couldn't balance plates on my hands, so. All right, so what we've got here, like I said, is an example of our rocket. So our rocket's going to launch, and because things aren't straight or because there's weight in certain parts of the rocket, it's going to want to go off in a different direction. What the fins then do is, they do the same lift that these wings on an airplane do. So when it goes one direction, the fins are going to take the back end of the rocket and push it straight up again. So what's going to happen is we're going to have stability, because though the rocket goes in a direction, the fins on the back are going to push it back to straight up, and that's going to be stability. Now, if we were the other way around, and let's say the weight of our rocket was back here, and we had fins at the front, right? The second that rocket points the wrong way, now our fins are going to push the rocket this way. That's bad. That's called instability again. So again, think of the ball. When the ball starts moving at the top of the hill, it's going to roll down instability. When the ball's at the bottom of the hill and it moves up a little bit, it's going to go back to its original position. That's stability. So that's what our fins are giving us.
Does that make sense, guys, when we have fins?
Yeah.
So what happens if I put the fins at the top of the rocket and I launched it? What do you think would happen to it? Go sideways, come back down. Any other options? What do you think? What was that thing I showed earlier? It's going to tumble. It's going to tumble all. It's unstable. It's just going to spin and it's going to be out of control. That's what unstable means, right? When I have the fins at the bottom, right? What happens if the rocket goes like this? What are the fins going to do? If it's moving this direction upwards and it hits the fins, what is the air pressure that hits those fins going to do? It's going to push it that way, right? If it goes this way and it's cruising up like that, what's the air going to do? It's going to push it back. So that's why the fins are on the bottom. And the other really key thing about this is the size of the fins, right? So I think our little example here was to show also, there's two things. You want to draw where the weight is versus where the fins are. So you see this two sticks, guys, here? This one's got the weight at the top. This one's got the weight at the middle. You can kind of imagine this as, this one has huge, huge fins way down low. This one has kind of small fins in the middle. And the trick is, which do you think is going to be easier for me to balance? And you guys can maybe try this. So there's me balancing this one. I can do it. You think it's going to be easier or harder to balance with the weight at the very top and the big, big fins down low?
Harder.
Harder? What do you think?
Easier.
Much, much easier. Okay? So the trick to these rockets that we're going to build today, guys, in order to make them super stable so they go straight up and they don't go tumbling through the air, right? Big fins, low. So here's some pretty big fins, and they're hanging way down low by the nozzle. See that? If I had these fins, let's see if I can pop this off here. I don't know if it'll come off easily. If I had these fins up in the middle, I can't yank it out. If I had these fins up in the middle, it might be stable, but then again, it might not. It might tumble. It might go straight up for a little bit and then turn sideways and go shooting at us, right? Now, these all have a tennis ball on them. So what happens if this rocket does go up and turns at you and comes at you? What are you going to do for safety? Now, maybe just cover your head, because this is just a tennis ball. It probably won't hurt you too bad, okay? It's a bouncy tennis ball, right? But I don't want it to hit you in the eye or the face. Just cover your face, okay? Hopefully, we're gonna check everybody's rockets and make sure you have those fins big and down low. All right? So we have just enough time to start making our rockets. We're going to do a 5-second countdown. 5,